Right about now, you may be asking yourself, why do we even need to calculate this molar mass stuff? It seems like a big hassle to me. Well, I want to try to answer that question using one of my favorite Valentine's chemical reactions and a bundle of pennies. Prize balloon inflate. You know, if you hit those, there's some kind of chemical reaction that goes on, and then eventually it just pops right out of that little package. And in that little balloon, in that little envelope, was this balloon, Be My Valentine. That's cool. Actually, it is kind of cool. It's much cooler than it was before. How does that work? Someone has to count the actual atoms and molecules of chemicals that are in there, because if they put in too many chemicals, it'll just make this balloon pop. It has to blow its way out of the envelope, has to have enough molecules to do that, but not so many molecules that it actually makes this balloon explode. What's going on? What's inside this envelope? How can we count the number of atoms? Let's cut open the small envelope and pull out the contents. Here are the contents. There's that balloon. How many molecules of chemicals are inside this balloon? Look at that. A white powder. I wonder what that powder could be, and a little packet of clear liquid. Now, what happens if I mix these? And did somebody actually count not all the little grains and particles, but did someone count all the molecules and atoms that are in this pile? Do we have a way of doing that? Now, what will happen if I take this and snip the corner off and then mix into that powder? There is some kind of chemical reaction going on. Now, do we have a way of counting how many bubbles of gas are coming out? It needs to be enough bubbles to fill this balloon and pop it out of this envelope, but not enough bubbles to make this balloon explode. How can we count those molecules? Let's say I have this container of pennies and I want to count them. How do I find out the number of bundles of pennies that are in this container? Well, that's kind of like being able to find out how many moles of the chemicals there are inside this container. Even though they're too small to see, I can still count them by finding their mass. I've got this pile of pennies. I'm going to count them all. But I can look at bundles of pennies. A bundle of pennies is about 127.80 grams. Now, I could use that as a conversion factor when I want to find the mass of the pennies in this box. One bundle of pennies has a mass of 127.8 grams. The big tray of pennies has a mass of 1,200 grams. So I can use the relationship up here. I can use that relationship to do the calculation. And it works like this. I'm going to rewrite that relationship so that this unit on the top is the same as this unit down here. So that means I'm going to write grams of pennies down here, and I'm going to write bundles up here. Well, I know that one bundle is 127.8 grams. So now I have used a conversion factor in such a way that these units factor out and leave me with the number of pennies, or in this case, the number of bundles of pennies. So 1,200, I just take this number that is on the top. I take 1,200 and I divide it by 127.8. And I have the bundles of pennies. That comes out to be 9.4 bundles.